Part 4, Determining Minimum and Maximum Values. Use domain values to determine where the function represented by the following graph is increasing, decreasing, or constant. When we talk about increasing or decreasing, we're talking about what the graph is doing from left to right. So this graph is increasing right here. So it's increasing from when x is 0 to when x is 1. And it's also increasing right here. And that is from when x is 2 to infinity. That arrow means that it's going to keep going forever. If we want to look at where the graph is decreasing, we want to know where the graph is going down from left to right. So it is going down from left to right here, and that is from negative infinity to 0. These intervals are the intervals of the x values, where it's increasing and decreasing. And then constant, the graph is constant. That means a horizontal line from when x is 1 to when x is 2. The next thing is a local maximum and local minimums. F of a is a local maximum on an open interval if for all x on the interval, f of a is greater than or equal to f of x. So this f of a, marked by this point right here, is a local maximum because it is the highest point on an interval surrounding a. So in its neighborhood, it's the highest or the maximum point. This is also a local maximum right here because in its neighborhood, it is the highest point. F of a is a local minimum on an open interval if for all x on the interval, f of a is less than or equal to f of x. So this point is a local minimum because that is the lowest value on the graph. So y is the smallest number of all the y values in its neighborhood. So this neighborhood could be as big or as small as we want, but that one is a local minimum. F of a equals b is the absolute maximum or global maximum value of a function if b is greater than or equal to f of x for all x in the domain of f. So this is an absolute maximum because if we look at the entire graph, so the entire domain, this is the highest point. F of a equals b is the absolute minimum value or global minimum value of a function if b is less than or equal to f of x for all x in the domain of f. This function does not have an absolute minimum value because both the right side and the left side will continue to go down, and so there is no absolute minimum value. Determining maximum and minimum function values. For this graph, we have a couple different local minimums. We have a local minimum right here. So we have a local minimum at x equals negative 3, and that local minimum is 0. The local minimum is the y value. We also have a local minimum on the graph right here, and that x value is approximately 1.5, and the y value maybe 1.3. So that local minimum value is 1.3. We have local maximum values also. Here's a local maximum value. That is the point 0, maybe 3.5. So our local maximum value in that neighborhood is 3.5. We also have a local maximum right here, and that local maximum is the 0.32. So 2 is another local maximum. The absolute minimum is the smallest point on the graph. So this one down here is our absolute minimum value. That looks like the minimum value there is negative 3. That point is about 4.5, negative 3. And we have an absolute maximum value, is this one right here. That one was also a local maximum value, but it is the absolute maximum value of the function. And so that value is about 3.5. Notice the local minimum and local maximum could not be endpoints of a closed interval, but the local or the absolute maximum or absolute minimum can be.